So example 4, we want to look at a recursive sequence. Right, the first 5 terms of the sequence defined recursively as a1 is 3, and then we have a sub k equals 2 sub a k minus 1 plus 1, and k has to be greater than or equal to 2. So in order to start this off, we already know that a sub 1 is 3. And so then the next term, that's why it says k is greater than or equal to 2, if we plugged in 2, so a sub 2 equals 2 a times 2, subscript 2 minus 1 plus 1. So if we simplify this more, 2a1 plus 1, a1 is our 3. Okay, a1 is 3 up here. So you're just substituting that in. 2 times 3 plus 1. So this is 6 plus 1, which is 7. So try the next one, a sub 3. So 2a sub 3 minus 1 plus 1. So that's 2 times a sub 2 plus 1. A sub 2 is this term here, so it's 2 times 7 plus 1, and so that is 15. And then, so really if you notice, you're just continually plugging in that value here. So the next one would be 2 times 15 plus 1, right? We're plugging in that previous value, and so this is 31. So 1, 2, 3, we need 5 terms. So 2 times 31 plus 1. And then that becomes 62 plus 1, which is 63. So therefore, the first 5 terms of the sequence are 3, 7, 15, 31, and 63. So try this out here, right? The first 5 terms of the sequence defined recursively as a sub 1 is 6, and these values down here. So try it out. So trying this out, so a sub 1 is 6, and then you plug in k plus 1. So let's start with, if you plug in 1, 1 plus 1 is 2. So you have 6 plus 1, right, a sub k. So that is the one previous to it. And then a sub 2 plus 1, you're plugging in the 7 plus 1 equals 8. And then so that is how you get these next values. So example 5, we're still looking at a recursive sequence. This is a famous one, Fibonacci sequence. And so the Fibonacci sequence is defined recursively as follows. So in this case, we're starting with a sub 0. It's convenient to have that sometimes. So a sub 0 equals 1. A sub 1 is 1. And then write the first 6 terms of the sequence. We have the first 2. We need to do the next values. So we're going to write, so k is greater than 2. So let's start with a sub 2 equals a sub 2 minus 2 plus a sub 2 minus 1, right? I'm plugging in 2 in every place here. So this is a sub 0 plus a sub 1. So I'm looking at a sub 0 plus a sub 1, and I'm adding them together. So 1 plus 1 is 2. Then I do the next one, a sub 3. That's going to be a sub 3 minus 2 plus a sub 3 minus 1. So it's a sub 1 plus a sub 2. So a sub 1 we know is 1, a sub 2 is 2, and so the answer is 3. Then the next one, a sub 4 is a sub 4 minus 2 plus a sub 4 minus 1. So a sub 2 plus a sub 3. And so, again, that's the previous terms. So we're looking at 2 plus 3, which is 5. And then, I hope you see that really what's happening is you're adding the previous 2 numbers. So 1 plus 1 gets us 2. 1 plus 2 gets us 3. 2 plus 3 gets us 5. And then 3 plus 5 will get us 8. So, it's just the practice in plugging it in there, of finding the values. Now, the next one is not a Fibonacci sequence, but it's practice in plugging it in. So find the first 5 terms of the sequence defined recursively as a sub 0 is 1, a sub 1 is 3. So if you tried this out, you had the first terms, 1 and 3, and then you would get 4, 7, and 11.